Hey everybody, Mr. Walker here with the instructions on solving the Big Ideas assignment lesson 8.4. So the goal of this video is to help determine corresponding side lengths of similar solids when given surface areas or volumes. So just a quick recap of what similar figures or similar solids are. They're going to look the exact same. All of the angle measurements are going to be the same. However, there's going to be some scale factor that's been applied to the similar shape that either made it larger or smaller. So a scale factor of something greater than 1 would create a similar shape that's larger. A scale factor that's smaller than 1 would give you a similar shape that is smaller than the original. So let's go ahead and take a look at our first question here. It says, which cylinder is similar to A? So we have here on this side, we have A, and we have two options. We have cylinder B or cylinder C right here. Let's go ahead and look at just the comparison between cylinder A and cylinder B. Let's start with A. Okay, so we see that the radius of this is 6, and then the corresponding side to that would be this 5 from the cylinder B. All right. Now, looking at the other pieces, it should be proportional to the other corresponding parts or the height of the cylinder. So 4 and 3. So a quick way to tell if something is proportional or not is to do something that I call cross products. So if you multiply the two numbers here and then multiply the two numbers here, they should give you the same product. So 4 times 5 is 20 and 3 times 6 is 18. So I could tell that this isn't proportional to each other. Now let's go ahead and check the other cylinder, cylinder C. So we have the radius of 6 for the cylinder A. Compare that to 7.5 from cylinder C. And then the height of cylinder A compared to the height of cylinder C. All right, so let's check and see using the cross products if these two are the same. All right, so I got 6 times 5, which is 30. And then using a calculator to multiply 7.5 times 4, I see I also get 30. So I could tell that cylinder A and cylinder C are similar solids. Their corresponding side lengths are proportional. Their corresponding side lengths are proportional. All right, let's go over another question here. So the cones are similar. Find the missing slant height of L. So one thing that we should probably note in the example is that it already tells us that they're similar, meaning they look the exact same except one is going to be larger or smaller. And the goal is to find the height of the slant for cone Y. All right. So let's go ahead and try to figure this out. So let's look at the corresponding pieces. The slant height for X corresponds to L, and then the radius on the bottom of the cone from X corresponds to the radius from cone Y. So let's go ahead and set up our proportions. So I'm going to put, since cone X is a little smaller, I'm going to put its measurements on the top. So this is the first numbers that I'm putting down are going to be from the radius. So 5 corresponds to 7, so 5 is to 7. And then on the other side, 13 is to L. So if I want to figure out what the answer is for this one, I'm going to do the cross products once again. So I'm going to multiply 5 times L and 13 times 7. So let's see, 13 times 7 is going to be 81. Oh, sorry. Let's go back. 13 times 7 is 91. And then 5 times L is 5 L's. Now, if I want to figure out and get the L by itself, I got to get rid of the times 5, right? So in order to get rid of it, I got to divide by 5. Divide that side by 5. 91 divided by 5 is going to be 18 and 2/10. So the slope, or sorry, the slant height, L, is 18.2. So remember, the key here, when I was finding out the slant height, was to set up a proportion. We had the radiuses of both shapes over here. And then on the other side, I put the slant heights. And you notice that everything from cone X was on the top, everything from cone Y was on the bottom. All right, so this is a section that I want you to make sure that you copy down, especially that formula down at the bottom. It says that it has to do with the surface areas of similar solids. So when two solids are similar, the ratio of their surface areas is equal to the square of the ratio of their corresponding linear measurements. So if you're looking at this example that we have here with the two cylinders, you have solid A and solid B. The surface area of solid A corresponding to the surface area of solid B would be equal to the square of the corresponding linear measurement. So they're using in this case, the radius from both solid A and solid B, and they would square that ratio. And you can see they wrote it here as a fraction to help you understand it a little easier. We'll go over an example here in just a second, but make sure that you copy this formula down here at the bottom. All right. We have a question here. It says the pyramids are similar. What is the surface area of pyramid A? So remember, when it comes to similar shapes, we know that their corresponding sides are proportional to one another. And in the case of the surface areas, we would square the corresponding side measurements. So let's go ahead and solve this one. What is the surface area of pyramid A? All right, so that's the one that we don't know. So I'm going to I'll put a question mark. Actually, let's use a capital A corresponds to, well, the surface area of B And then we're going to square the ratio of the corresponding side lengths. So for A, we know the 6 corresponds to the 10. So first thing that I'm going to do is I'm going to square that side first before I start trying to solve. So A is 600 as 36, 6 times 6 is to 100. All right, so in this case, if you want to try to figure out what one of your missing numbers is, you can find it by doing the cross products. So we'll do that way, and then I'll show you a separate way here in a second. All right, so I'm going to get, let's see, 100A when I multiply 100 times A, and then multiply 36 times 600, which is 21,600. All right, I need to figure out what the A is all by itself. So how do I get rid of that times 100 in front? I need to divide by 100. So if I divide 21,600 by 100, I get 216. So the surface area of pyramid A is equal to 216 square feet. Now, one way that I could check to make sure that I got something reasonable and close to being right is I knew my answer had to be smaller than area B or pyramid B's surface area because pyramid B is a larger pyramid. So the surface area should be less than 600 square feet. All right, now when it comes to the volumes of similar solids, when two solids are similar, the ratio of their volumes is equal to the cube of the ratio of their corresponding linear measures. So when looking at the example that we have here, the volume of solid A, which corresponds to the volume of solid B, is equal to the cube of the ratio of their corresponding linear measurements. So again, in this case, they're looking at the radius of cylinder A and the radius of cylinder B, and then cubing it. So remember, when it comes to volume, you're also working in cubed units, which is how I remember to cube it and not square it. All right, last question. The dimensions of the touch tank at an aquarium are doubled. What is the volume of the new tank? All right, so in this case, if we remember back from our previous slide, the volume of similar solids is going to be the cube of the ratio of the corresponding side lengths. All right, so what they tell us here is that the volume of the original is 2,000, and they're going to double those dimensions for the new tank. So the ratio from the original to the new would be 1 to 2. Every one length from the original, which would be on top, is going to be doubled for the new. So that's the ratio of the corresponding side lengths. So let's go ahead and set up our proportion. So the volume of the original, which is 2000, corresponds to the volume of the new, which we don't know, I'll just call it V. And the ratio comparing the side lengths of the new and the original is 1 to 2. And don't forget we have to cube that. All right, so let's do the simplification first. I'm going to cube the right-hand side before trying to solve for V. Let's see, 1 cubed is 1. 1 times 1 times 1. 2 cubes is 2 times 2 times 2. So 2000 is to V as 1 is to 8. So with this, we're going to do our cross multiplication. And I do 8 times 2000 and get 16,000. And then 1 times V, well, 1 times V is just V. So the volume of the new tank is going to be 16,000 feet cubed. You're thinking, well, Mr. Walker, why didn't we just multiply it by 2? Because everything is going to get doubled. Well, the reason that we just don't multiply it by 2 is because in the new tank, we're going to double the length, we're going to double the width, and then we're also going to double the height. So times 2 times 2 times 2 again gives us 8 times bigger than the original. We're cubing that number. Kind of comes back to our cubing that we did at the very beginning. All right, everybody. Make sure that you have your notes completed for today. I will be checking your notes the next time we see each other. Have a good rest of your day. I'll see you next time.